Welcome back for the third video in a series of building a vacuum tube guitar amplifier from design to plug your guitar in it and rock out. Um, this is where we left off in our last video, in video two. In video two, I gave us, to start off with, specifically this voltage going to the plate when we were trying to figure out our values for the cathode bias resistor and the load for the transformer. So I promised this video, it's going to be a shorter video. I'm going to show you how I came up with 115 volts DC for the supply. And we're going to be working out of PSU Designer 2. And I just want to take a moment to say I'm not affiliated with any of these. These are just what I particularly like. They're free. You don't have to pay for anything. If you haven't downloaded this, go ahead and do so now. You don't have to. You can just follow along if you want. But let's get into it. So when you download it and open it up, this is what you're going to see. And what I'm going to show you is over here in the upper left-hand corner, we're going to work from left to right. I'm going to show you what to put in and how I came up with 115 volts DC. So let's go. First things first, we are doing a half-wave rectified series heated amplifier. And this is a low volt amplifier, and our transformer has 120 volts. So right click, left click, and let's change this 333 to 120 volts to match our transformer. Don't worry about the source resistance for now. Next thing we're going to do, as I mentioned, highlight all of this, right click, left click. We're going to change from solid state bridge to half wave rectifier on the vacuum tube side. That will change us to that. And then, so this is 220 microfarads, and it's what they left in there. And normally for a vacuum tube amplifier, you would not use this much. But this is not a normal vacuum tube amplifier. This is a half-wave rectified. And we are going to use a tube that can handle this. So for today, we're not going to worry about this 220 microfarad. We're just going to leave it the same. And I'll show you real quick. This is the tube we're going to use. This one here on the left, it is a PY500A. It is a very stout tube, and it can handle everything we need it to for this design. Likewise, this transformer, you might be like, well, why wouldn't you use higher voltage? Well, this transformer is $20. And you could pay $100, $200, $300, even $1,000 for a power supply transformer for a vacuum tube amplifier. I am not doing that because I am not made of money. So this is what I want to design around, something I can afford to build. And then I'll probably sell it and I'll probably lose money on it, but it's my hobby and that's what I do. So that's why we're using that. And in combination with this tube, right click, left click, we're going to change this to our PY500. So just type in P and it should come up right away, or you can just scroll down here and hit OK. Now we've changed that. So all these values are good. I should point out another reason for using this PY500. Go back to the picture here. So our power output tube, the 25BQ6GA here, is 300 milliamp heater. So to do a series heater, which is what you do with low volts, so you don't have to buy a bunch of heater transformers to power the heaters, you need all your tubes to have 300 milliamperes. And it just so happens that PY500 fits that category. And when we start talking about the preamp, I'll show you another reason why that 300 milliamperes is important. But moving on, let us highlight this whole section here. Right click, left click. We're going to change this to constant current. Okay, so 100 milliamperes is what it will automatically populate with. We need to put in our total milliamperes for our whole amplifier. You can guess this, which is what I did to get in the ballpark, and it will be reasonable. Originally, I think I guessed 65 milliamps, and still came out with the same voltage. So, I mean, there's lots of play in there. But you'll notice we wrote in these milliamps. You'll notice mine's a little different, and that is because I added 2.5 milliamps from where we left off for the preamp. So our total milliamps is going to be 72.63. I will show you exactly how I came up with that in a not next video, but the video after that. So our next video, we're going to do complete the power supply with all the numbers and everything. But for right now, 72.63 milliamps into the designer. Right click, left click, 72.63. Okay. Now, what we're going to do is we're going to hit this simulation button. And what we're looking for is the voltage that's coming out of this capacitor. So this capacitor is C1. We're looking for volt C1. So we'll click on that, and that will show us this graph. I'm going to highlight this for. So you see, there's, if you round up, about 128 volts RMS. So why on earth would I decide that 115 is appropriate? Well, I'll show you. So we have 128 volts from here to here to here. So let me say that again. From this point to this point, we should have 128 volts. But from this point to this point, we're going to have less. Why? Because our cathode bias resistor has a 13 volt drop across it. So if we put in 128 volts right here to this point, then we have to subtract our 13 volts from that total. So what you come up with is 115, because 128 minus 13 is 115 volts. So that's what we're looking at for an in. What's actually coming in here is 128 volts. But we're losing 13 right here. I hope that makes sense. So from here to here is 115 volts. And then from here to ground is 13 volts. And from here to here is 128 volts total. So that is why 115 volts. Now let's talk about grid number 2. Why 115 volts in grid number 2? Well, because I decided on 115 volts DC. I did not want to surpass that for my grid. So it was just a convenient number to start with, and it ended up being good in our design. So that's what I stayed with, 115 volts. I just started there because I didn't want to pass this. No other reason. Now, let's go back to this for a quick second. Now we know why I decided on 115 volts, because the supply voltage was about 128. Now let's look at this for a second and compare to this capacitor. So, if you select an area down here, it'll expand this, and you'll see there's these peaks, these low peaks and these high peaks. From peak to peak, we are looking at 1, 2, 3, 4, about 4.5 volts. It goes down a little bit here, but it's about 4.5. So peak to peak in a single ended amplifier, you cannot have more than 5% variation on your RMS voltage. So let's check out and see if this complies, and I'll talk about why. So bring up your calculator. And we said we had 4.5. So if you divide that by, we'll round up to 128 volts by our RMS voltage, and then multiply that by 100 to get us to our percent, you've got 3.5%. And I said as a rule, you can't go past 5%. Why? Because, wrong thing. This will actually make noise. This is your filter cap or input cap. And if your peak to peak is too high, this will hum. You will hear it. It will make a buzzing sound, and it will be very irritating and not very much fun. But let's take a look, see, and show you what would happen if we picked a lower capacitor, just so you could see that. So we're going to go with 22 microfarads. I'm going to simulate. We're going to have to back off because now our peak to peak is way higher. I mean, it's like right around 9 volts, I think. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. We'll just call it 9 volts. So 220 gave us 3.5%. 22 microfarads is going to give us quite a bit more. We're looking at 7%. That's 2% over the 5%. And I mean, you can just tell by looking at it, it is not pretty. It's a very ugly signal. And here I'll come out even more. That is not what we're looking for. So I'm going to switch her back to 220. That being said, you might ask, well, why not make it 470 microfarads or 1,000? You could do that, but that would be pretty strainful on the tube. We want the tube to last for a while. And it gets to a point where this is kind of impractical. Like we'll squeeze it down to just a line that we could do it, where it would just be, 1 volt, but it would be really expensive and it wouldn't be any better than this, really. Unless you were talking about audiophiles. They need really clean voltage because they don't want any distortion. And in tube amps, this is where that starts. But anyways, if you have any questions, let me know, and we'll go from there. Our next video, we are going to make the. Did I just put it down again? We are going to go ahead and lay the schematic out for the power supply, and then we're going to figure out all our capacitances and resistance for each step of our circuit. And then the video after that, I promise we will design the preamp, and then we'll go from there. So if you have any comments, go ahead and make them. I take all comments, polite and hateful. I don't mind growing at all, but hopefully you got a lot out of this. And please let me know, and we'll keep doing more videos And when we're done with this amplifier, maybe we'll do another build along with a different amplifier or a different, who knows, we'll do other pieces. But thank you very much for following along, and I hope you have a great day.